Awesome. Thanks, Lawrence. Yeah, very much appreciate the same. Lawrence is supporting us. So we are actually going to have more and more meetups here at Google Cloud. So my name is Yongkang He. I set up the Meetup group back in September last year. So far, we're growing very quick, and we just got almost 1,200 members. So considering this size, we do need a lot more people to support us. So actually shortly, Boomi will talk about our volunteers. We actually do have 15 volunteers to support us right now. And because of the size is growing, we do want to introduce more and more meetups. And the next one, we are actually doing a hands-on learning based on the GK, Kubernetes, and also backup. So just to welcome everybody to join us, to continue to join us to learn Kubernetes. It doesn't have to be, Google GK. It can be any other Kubernetes ecosystem related stuff. So my name Yongkang He. You see the t-shirt. I actually don't work for Google. I don't work for Google Cloud either. Surprisingly, I did you guys try ChatGPT? I tried to ask ChatGPT, who is Yongkang He? They told me I work for Google. I was thinking you might have predicting, one day I might have joined Google. I hope it will happen. Anyway, just to welcome everybody to join us, and because our size is growing, I split. We are going to have 3 groups to continue to run the meetup. So today we got Boomi. He's our leader for the group 3. We're going to have to hosting the event for today. And moving forward, we're going to have group 1 and also group 2 to continue to run the meetup. Very importantly, we do need more volunteers. We do need more sponsors and more, speakers. So feel free to join us. Shortly, Boomi will display the links. So if you are interested to join us, you just go to fill out the form and you can join us. With that, let me hand it over to Boomi.
Thank you, Yoko, for the wonderful introduction. Good evening, everyone. I don't see any energy. Say good evening. I think that's Lawrence. Lawrence, pizza is not good. I don't see energy from the people. Okay, good evening. Yeah, now it's good. Okay, so the purpose of Kubernetes, right? The purpose of Kubernetes user group is to share and learn the Kubernetes among ourselves. That's the whole purpose. So Yongkong created the group last year, Meet, then followed by Chirag and myself joined as a co-organizer. And so far, we are running like multiple user groups on another title of Kubernetes, and we welcome each and everyone. For example, if you have like topics, come and talk to us, anyone like myself or Yongkong or Chirag or like Sachin, anyone, like just come and talk to us. If you have like any customer case studies you wanted to share with us, just feel free to share with us. That's the whole purpose of the group. And as Yongkong mentioned, we have divided the group on 3 categories. So that may be the reason I see like some of my friends in LinkedIn ping me, hey Boomi, I see like February 28th also scheduled. Are you going to be there? Because that time I will be talking to another event. So it's not, we have like kind of like a stateless, the Kubernetes stateless architecture, we made it here. So it will be like a three groups. 1 will be led by Yongkong, and 2 will be Chirag, and 3 will be myself. Today, this is part of like a group 3. And today we have like Sachin also. Sachin is helping us, and he is supporting from like a last group onwards. Apart from that, if anybody you wants to be a volunteer, just let us know. I'll go through that. And I would like to thank our sponsors. First and high priority is more focused on Google, because Google Cloud, because of the Google Cloud, maybe I would say that strongly, we are getting the space. We are always face a lot of struggle in finding the place. This one will be solved by Google Cloud. And Lawrence, thank you very much, Lawrence. Okay. And other sponsor like a CloudCasa and JFrog. CloudCasa, I think if you follow Yongkong session, right, you might know what is CloudCasa. He was kind of like a global ambassador for CloudCasa. So keep on talking that. It's kind of like a backup as a service. And JFrog is DevSecOps and observability kind of tool. And thank you, our sponsor, once again. Okay, this is the important page. I would like to thank each and every one of the volunteer groups, starting from Nazir, Hanning, Ritesh, and if you don't know Ritesh, he's just like taking the photo, and Sambat Karan, Pazir, Srinivasan, Angie, Jatin, Nakib, Lim Benchop, Jason, Anupama Soni, I think she's just standing. Women in tech is very important, and we are seeing a lot of women are coming into the group. We really appreciate. Please invite your friends also. Let's get moving. Kalyan, Raghavendra, and one more lady, Anshika Gupta. Okay, and it's going to grow further. So these are like a banners. We're just getting started. Maybe we would need your input also. Which one could be good? Either like this one, maybe you can consider like this is A or this is B. Which one? Maybe whoever likes A, just raise your hand. Okay, 1, 2, 3, 4, 5. Whoever likes B, just raise the hands. 1, 2. I think B is majority, so we can go with B. B is this one, like perfect. So this is the LinkedIn page which I'm running on it. In case if you wanted to know the updates, when it is happening, who is the speaker, because if you see in your email, right, there are like multiple meetup links are coming. If you're active on the LinkedIn, just follow this group, Kubernetes user group. Okay, it's kind of like learning group. We will try to share whenever the events is happening with the speaker details and all. You can make a note of that. Okay, this is the group. Please feel free to follow that. It's already nearly like 60 followers already there. I still not British outside. Maybe you can just get following that. So in case if you want to be a volunteer, just fill up the form and sponsor and also the speaker. In case you want to share anything, please fill up here. This is like some of our few the previous Kubernetes user group. You see, like we have conducted in Red Hat, AWS, Google, and also Rakuten. We have like other CNCF ecosystem vendors also. Like next week we are going to have in SysDeek also. Not next week, next month. Okay. I think that's it from the introduction on the things. Do you have any inputs you wanted to share before we move on to the purpose of today's session? I think we're on time. Any questions, guys? They're going to start in 4 minutes. 7 o'clock is the actual topic. So these are like today's topic. First is I'm going to talk about demystifying cloud native. I'll tell you why I choose the topic. What is the feedback I received from like last 5 to 6 groups. I'll tell you the reason, and it will be more kind of like introductory. And I expect each and everyone to come and interact with that session. This is kind of an interaction session. Second one is Kubernetes HPA with custom metrics by Hairizuan. It's going to talk about the topics, also how it is going to help in the production as well. Okay, the third one is something interesting, Kubernetes in prod and how to run. Okay, so this topic, like he mentioned, like he learned the Kubernetes in the production environment last 2 years, and he wants to highlight that, and he wants to share across the wider audience. That's the third topic. And the final one, in case if anyone wants to come and talk to them. For example, I heard like one of the guys in one shop, they told like, hey, I'm looking for some platform engineering opening or DevOps kind of opening, right? If anyone looking aggressively job, just come and talk to them, get connected. Or if anybody has an opening, you just come and say, this is the opening in my company. You want to do that, because the purpose of community is not just like learning, right? Learning, you can just go to YouTube or like attend the webinar. You can learn everything in more sophisticated way. I need to be just honest, but the purpose of community is be the experience. Come and meet the real people, talk to them, what they're facing challenges with the customer environment, and what you can learn from them, and what is the value you can create to each other. That's all about the community. Okay. So we have like upcoming meeting at like 28th February. It's more towards hands-on, and sync on like 14th March, and again Google on 21st March. Okay, so don't forget to fill up the form. Okay, thank you very much on the introduction. Okay, thank you very much on the introduction. So I'll go through the my topic in case we have any questions. Okay, so who benefits in the cloud and why? This is the purpose of this session. If you understand this concept, you are done. So whatever the traditional applications running in the cloud is more kind of cloud-enabled applications, which are running on the virtual machines, or either like there could be like a shared tenant, whatever it could be. That is our called cloud-enabled applications. With that, we have some issues in terms of scalability. That's the key thing. And consider the Grab app. If you're building the super app, right? If you're having the cloud-enabled app, we may not scale. And if anything, we need to come back and do the changes, right? If you see that if you're using Grab, one day you may see the neat UI, the new features. Next day, maybe the new features. How we cannot build this kind of things if you are having the cloud-enabled app. So cloud-enabled app is nothing but the same application that can run on data center also. Okay, so cloud-native application is build split the applications into microservices way. There are like multiple virtual machines are there or bare metals are there. From there, distribute the application components. For example, what is the web doing? What is the app doing? What is the DB doing? Inside the web, what is the front end? And what is the communication layer? Who is talking to the DB? So just split everything as a service. How are we splitting? As a service. That service is called as a microservice. And assign each service to either group of containers or like a single container for the specific job. And the specific job can be assigned to one set of developers or a single developer to focus on that task control. That is called microservices. Okay. So what is the cloud native benefits? The first one is increased efficiency. How? Because now the developers are more kind of independent. If anything needed, they can focus on the code level. If anything fails, they can come back easily, test it, and they can easily build it. And if you from the infra background, how long from anyone from the infra background, right? I just wanted to check with the question. How long to power on and power off the server takes a time? Oh, you mean to say like the physical server can boot up in 5 minutes? Oh. Okay, I'm saying like a server, then only you need to virtualization, then only the actual OS. I'm saying there are 3 things, right? Okay, consider there is a power outage in your data center. That could be any server, and if the server runs on the ESXi and your application running for the VM, how long the downtime could be? Right? Okay, the latest service is it's a 27 minutes. 27 minutes downtime if you're running an application, if any power outage happens. So 27 minutes, if you convert the SLA, you are lost, right? That's where the cloud comes into the picture. Someone can go on that and we can have like a high availability, one availability zone, another availability zone, even like multiple regions. That is the another version of cloud native also, immutable infrastructure. You don't need to like upgrade or downgrade the infrastructure. Whatever maybe happens, just build the infrastructure. Okay, and then reduce cost. You already know like what is the server cost and what is the VM cost, and what is the compute, how the cost is calculated. Cost is based on for the specific application, what is the need? What is the need of compute and memory and storage and the network IOPS, right? Even if you're running any, just come back, think back like 5 years before, if you're running a VM, right? If you open the VM performance, right, it won't be there all the time 100% utilized. Did you notice that? That VM won't be 100% utilized most of the times. Maybe like only few times the VM will be utilized. Okay, but in the container, you are running that application or the microservice for the specific purpose. So it will run. So once it's done, maybe you can delete that or you can recreate it. That's a part of increased efficiency. Second one is reduce cost. Of course, what I told. And next thing is ensure availability. You can run the container in any places. That could be one cloud or multi-cloud, a hybrid cloud or data center. Okay. So what are the 5 key components of cloud native architecture? Someone told about 12-factor auth, right? If you see back the 12-factor auth or anyone, if your software architect comes into the picture, he will see the cloud native in 5 lenses. First is how your application is immutable. The application meaning the application infrastructure is immutable. Immutable means you don't need to work on either upgrade or downgrade the infrastructure. That infrastructure has to be stateless. Second one is microservices, you are aware, and API. And third is service mesh. Service mesh is how you are interconnecting your containers. And the final one is the containers. So let's see container benefits. So container benefits is more kind of like a almost instantly. Somebody told like a 15 minutes also like for the VM, the server boot up, right? Can you tell like how long it, maybe how many seconds it requires to boot up the containers? Depends. That's a good answer always. But I'm saying average. In seconds. Just think the average answer is 27 minutes, 2 seconds. How much that one? That's like another thing. And we can scale it efficiently. The Grab is super app is there, like we can build like multiple apps frequently, and anything happens, they can come back immediately and switch it off and recreate again. That's the beauty of containers. Okay. So now coming back to the developers lens, what is cloud native application development? Okay. So these are the development tenants: continuous integration, continuous delivery, DevOps, and serverless. And right now, there is one more concept called platform engineering. So under the platform engineering, everything will be part of that. So you guys know what is the purpose of continuous integration? To agile, to increase the code, make sure there is no error there, nobody should be deleted, those kind of things. And continuous delivery is continuously deploying that app, web app, or anything like code apps into the cloud. It's kind of like how we are building the application, testing the application, and deploying the application. That's what we call it DevOps also, right? And serverless. Serverless is much more little advanced. Even if somebody says, hey, I don't want to manage the containers, that is what like a serverless comes into the picture. But serverless has its own limitation. You cannot do much customization also. Okay, it depends. So for how do you choose this application is good for cloud native or not cloud native? Before I talk about the benefits, maybe I wanted to hear from you. How do we say? Awesome. Okay, maybe can you little elaborate? First is 3-factor. How do you do that? Maybe you tell me like key characters.
But as I was saying, if your application can be broken to multiple functionalities, and each functionality can sustain itself rather than tightly coupled or loosely coupled.
Yeah, that's the word actually. If your application is loosely coupled, if your application is able to do the loosely coupled native, then that's the best pick for cloud native. Okay. Okay.
So when we are saying that we are doing app modernization, so it will be comprising of different parts, refactor, then rebuilding, reshifting, right? So it starts with lift and shift.
Yeah.
Easy, simple one. Why? Because major of the companies do not have the budget to do the full migration.
Yep.
Then in the parallel, we start the decoupling part, right?
Yep.
And we make the decoupled applications, we containerize those, and we parallelly, switch those with the monolithic ones. Then we are in the production stage.
Okay. Okay. Thank you. So coming back, anybody wants to answer? Because I have like another 5 minutes only. I'm going to complete it. So how do we choose this application is cloud native? It can be, as you told, right? That's a journey. So that's the journey for the existing application. The existing application is migrated most of the time. I can say like 99.99%. No customer will use the cloud native from the on-premises. They're not going to migrate. They migrate using the lift and shift. From the lift and shift, they have like end-to-end visibility. They can use like some level of observability tool like app dynamics or new relic or to see what is the dependency of the application. From there, they discuss with all the developer team what are the functionalities can be decoupled. if maybe only the top layer, web only can be decoupled today, but DB cannot be decoupled. So take only the web, do the microservices, do the things. Once it's completed, then come back to app layer, then come back to DB layer. And DB, most of the times, customers still in the production, not using the cloud native. It's still in the normal cloud enabled mode. Okay. So some of the benefits of the cloud native application is faster development, you know that, and then platform independence. Why it's a platform independence? Why? Awesome, because it's abstract the infrastructure layer. What containers does, it's totally abstract the infrastructure layer. Same container you can run on cloud A, cloud B, cloud C. That's the whole purpose, and that's the reason like a lot of adoptions are happening. Okay, how many of you? This is my maybe like I have 3 more minutes. Just wanted to ask this one. How many of you know CNCF? I think most of the people knows. That's good. So they take the front end and do the cloud native journey. Okay, they're like a group of ecosystem also. So these are like CNCF members. You see, you can say like whatever the modern companies, also like traditional companies, everybody part of the CNCF. So what does that mean? See, like cloud native is real. It's not something they are going to do. Before I come to the meeting, right? Like before I do the presentation, I talk few people, one from like a platform engineering background, and others from like a DevOps background, others from like infrastructure. I asked them, I asked only one question. Are you guys using cloud native in your customer environment? I asked, right? Most of the people told yes. The same question I asked like a couple of a year ago. They told our company has a strict policy not to move to the cloud. Sorry, not a year. I'm saying like that 5 years before. They told our company has a policy not to move to the cloud. 2 years before, they told our company has a policy not to refactor the application, because a lot of people don't know. The shift you see, right? Generally, if you remember the Moore's law, right? Moore's law is saying like every 10 years there could be a change. It will be kind of like a down cleaning. But the actual things right now happening is just 2 years. And cloud native is going to become kind of like a next to boom. Just get started. This session is kind of like eye-opening session. Okay, to understand from the infrastructure point of view, also from the developer point of view, also from the business point of view, also to see the journey, how it can be done, what is the business benefit, how a developer can approach that, infrastructure people can approach that, and also business can approach that. Okay, if you have any questions, I'm happy to take. If not, maybe I'll have like 2 minutes to take the questions. Any questions?
So the moment we go into using that add-ons which people do that upselling, right? So we go vendor lock-in. So there are regulations. I work for a bank as well. Now there are regulations. Let's say I go too deep in cloud native when using the serverless architecture in AWS, for example. I can't do lift and shift to Google Cloud. For example, S3 is not available in Azure. Maybe GCP has another option for it, but it's not a lift and shift, and it is not like same like containers. Specific to Kubernetes and containers, maybe it's platform independent. The more and more we go deeper and get adopted, maybe it's like alpha. So you go and start using it and like Lambda functions and things like that. So you will get into a vendor lock-in situation that it's not a lift and shift anymore. So you should know the balance actually.
Yeah, that's correct. And one of the disadvantages of the cloud native, maybe the 2 disadvantages I would say is the learning curve. It has a lot of things. Maybe people think like cloud native means only Kubernetes or containers. Not only that, it's much more. Observability is there, and also like connectivity, security, and somebody told like zero trust. Security is very important in CNC. And the thing is, currently, most of the times, these kind of services natively available in cloud, and it's kind of like a lock-in. But a good architect can do the trade-off. That's where the actual architect job. And you ask, right, what is the role? That's where we are there. We have to balance. We have to trade off. Where we need to use that. And it is also not true all the services are locked with the cloud. Most of the time, that's why like CNCF have like a third-party ecosystem. The important thing is it has to be platform independent. But it's a journey. I agree with you. That's a journey. So any question? And that's a good question. That's a good question to highlight, because when we are talking about the advantages, we also need to know what is the disadvantage, right? So any questions? Maybe I'll take another two questions. Okay. Okay. Cloud native membership is kind of like open source, right? They help the community to grow. In short, if I wanted to say, there could be like an example. Since I'm part of Cisco, maybe I'll talk from the Cisco point of view. Cisco builds a lot of cloud native applications and brings to and share to the CNCF. If you take like Google build GKE, Kubernetes, and push to open source, and it's maintained by CNCF. And CNCF build a lot of open source projects also funded by this company. It's kind of helping the business journey actually. Good. Any questions? Any one more questions? Just last question before I. Okay, this is the key slide. Who owns the application? Everyone.
Okay. Hello, everyone. Okay. So I'm going to be talking about Right, but then you have to show how it can be deployed, how to run, how kind of check that properly and stuff. But again, without monitor the metrics, this feature could be a possible use. But if you have bare metal and then you're already running to its max, you can't exactly scale up and scale down as much. Maybe other frameworks might be better, which allows you to scale down to 0. I heard of this framework called KEDA, KEDA or something. KEDA, yeah. It's like based on like a quick look on the documentation, it sounds like it can scale down to 0, but I've never tried. So yeah, I need to kind of read the documentation and like find out. Yeah.
This is good. Yeah.
If the questions offline.
Okay. So if there's any other questions, you can. Oh. Yeah.
Let me.
Okay.
Yeah. You can please need to pause the question and disconnect the laptop.
Sorry. Okay.
That can you come? Because we are running out of time.
Hi, my name is Jack. My Chinese name is Liu Shurui. And today I'll share some experience in the past 2 years using Kubernetes in my product environment. I actually for introduction. Sure. Here is the agenda. First, introduction, self-introduction. Later, I explain my environments. My Kubernetes environment and some lessons I learned in the past 2 years, 2+ years. Okay, self-introduction. Okay, I work in the ByDot, a small company, solution architect. My experience as solution architect is about 10 years, 2+ years. I'm very interested in the cloud, Kubernetes and DevOps, SIE, and this kind of thing. Yeah, and my social link, yeah, GitHub is here. First, about me. Okay, so here is my environment. Basically, remind you, our system is running on Kubernetes, the cluster. I prefer to externalize our status in using many services like S3, RDS, Redis, like that. We also consider using the EFS and yeah. In our environment, try to adopt a lot of new things into my environment. And the DevOps principles, the 12 factors, and beyond. Here are some key things I use in my environment. I also I'm still learning and try to use this kind of thing. I mean, SIE principles and platform engineering. There are a lot of new things. Maybe you encountered it before. However, this case is I cannot find the solution in the link. Maybe I'll give you the link. You can. Okay, you cannot see that. Okay. Okay. Yeah. It's a better. Yeah, makes sense. Sorry. Yeah, there I have several common reasons. My case is I cannot find the solution from here. You mean I mean I cannot use the key control, get events, and to get logs from the course. So here is my reason. Yeah, here's the actual reason.
Presentation.
Yeah. Okay. After trial, this is all the measures in the link. So I cannot find a solution. So I look to the status of the pod status. So I find the error code, and finally I figure out the reason for the system or the code, the bug in our code. So make some change in there. I mean, the whole point here is that sometimes you need to check the last status, the error code. Yeah. I think, yeah. I mean, the second lesson I learned, yeah. So let's do the observability stacks. Usually I prefer using the in cluster way. I mean, I run the hierarchy stacks in the cluster. So what's the catch? Definitely, there's always a trade-off. Yeah. Here write down compared to 2A. Yeah, you can see here. I attended several interviews, being asked a lot of Chinese things, and finally I figured out that actually I should prefer using this way, the out class way. If there's something wrong, you still can check the log. You can get the metrics. If your cluster the observability stack in the cluster, if there's something wrong, you're screwed. You cannot find anything to resolve. How to resolve? Okay, and this is maybe it's too fast.
Then what do you do to monitor your monitoring solution? Now, how do you make sure that your monitoring solution is not good?
Well, that's a shiny one. Actually, I'm still learning that. I'm not sure. You use a managed service?
So that's because my company had such a reputation. So the monitoring solution went down, and basically everyone didn't know what happened to production for quite a while until the monitoring solution came back up. My company is like Acronis had a situation where the whole monitoring, like ELK stack, which we did out cluster, the whole thing went down. And it took a while for the whole thing to come up. So like right now, I haven't seen like what exactly they are going to do in terms of to monitor their monitoring solution. So yeah, just a curious question, because I heard from a story from a friend that was talking about AWS's journey about CloudWatch, where they use CloudWatch to monitor their own CloudWatch. So I don't know how true the story is. I haven't, like, until now I couldn't find the article about it. So yeah, just a curious question.
I read an article from the Alibaba. They have a similar solution. So the monitor, not monitor. It seems to be there's no way to resolve this kind of issue. Yeah. Okay. Yeah. The in-class is very easy to set up. You just define a YAML file and boom, the class ELK get up. It's very easy to start with the ELK operator. Yeah. Okay. This is CNCD. Yo. This is okay. So this is lesson 3. When I joined my company, the first one joined my company, I tried to take the initiative to run our system in Kubernetes. There are several choices when I set up the CI/CD. Is one using the managed service like the GitHub Action or the GitLab CI/CD pipeline. Yeah, I try to put our CI/CD pipeline in Kubernetes cluster. So I compare a lot of options. So I think this journey I learned a lot. At first, I compare all these several options in the cloud native way, I mean Kubernetes way. I want to put everything in the Kubernetes. So I compared the Flask, Argo CD, Jenkins X, and Go CD. I compared to the different criteria. I'm like the community is active and the developers in the repository and the stability. Finally, I choose the Argo CD at last. Argo CD, I very like the Argo CD because the Argo CD, Argo have a ecosystem. They also provide other services like Argo workflow. Argo workflow is used in a Kubeflow. Is quite Argo workflow also can use the CI. Yeah, I mean like the CI pipeline. The Argo CD is actually the CD pipeline, and my system is using another one in the action runner. Run the GitHub action in our cluster. The good thing about that is we have the environment in our control, so we can enter the environment to see the step by step, have some log, see something you cannot do in the GitHub pipeline, GitHub action. Yeah, there are a lot of things. During this journey, I learned a lot of things. You see here a lot of ways to speed up the building. I'm not sure maybe you know about it. So at first I use a stable runner. Usually the best recommendation is we're using a stateless runner. So every time you get pull the whole change, if there are commit, you check out all the changes. That way is very slow. If your repository is very big, so the performance is very, very bad. And so I use a stable runner. The Git have another, Git commander have a very useful command. I mean the Git work tree. So each commit, each run, we check out a different work tree. So we build from there. So to avoid conflict, complex. This is a code level and a runner level. I also use the several other Docker hacks, the Docker new technologies. I think the calculator. We also consider use our system is a mono repo. Yeah. So a lot of components put in one repository. So to reduce the building time, I use a lot of context and in the Docker context. So this one can speed up the building. Also using the multi-stage building feature in the Docker in Docker. I also use several mechanisms in the language specific, like Golang. Golang have a cache. Java and .NET all have this kind of cache mechanism. So at first time, maybe it's slow. After that, it quite put into perspective. Usually, each component will spend about 5 minutes after this feature building. This all three solutions put together, we reduce to less than 10 seconds. Yeah, reduce a lot of time. The building mechanics I'm still learning. This one, I tried a bit down, and it is very, very fast. But the below the building on based on the dependency, maybe you can read an article from the Grab using Bezel. Yeah, they use these tools can reduce this building time a lot. Another thing is, this one is a conflict resolution. In my CSV, we try to, after the system compile, we will generate a Docker image. We will put in our what's it? Okay, so this way. I use GitOps principle in our system. If there's as you know, if we have a lot of developers, we will commit a lot of changes. Definitely, there will at the same time there will some changes here occur. So at this time, we will change after the build the image, we put in the image. I mean the text or the command ID in the YAML file. I use a customization. Maybe you already know about this. Okay. Which one? No? What's mine? Okay. 我这样可以过来。没关系，这里先到这里，先把它关了。OK。再过来4.0。OK， 呀，4.0。对吧？用这个吧。Yeah, it's good. Yeah.
What up?
Okay. It's okay.
I think.
Oh, maybe there's one dasher. Oh, not a dasher.
Yeah.
Okay.
Is checking.
Yeah.
Check.
Hi. Oh, it's not. Huh?
I think you can. Yeah.
Hello. Okay. Yeah. I use these tools to customize. I mean, these tools support component based and allows the customization. I mean the same configuration for different environment. And for example, in our system, we're using developer environment and staging environment, and we also have brands. Yeah, it is very useful. Yeah. There's one thing. Sorry. Okay. Okay. This is one thing. After the CI/CD build the image, we try to use the same principle as previously talked about, the immutable infrastructure. So we're using after the image pushed in our Docker image registry, we don't change that again. So we try to we only update our configure file, the customization YAML file in our system, and like this one, I'll show you one. Like this one. We're using a different environment. I like this, that staging. Yeah. The basic file is a customization file. Okay. Yeah. Like this, we're using a lot of JSON patch. Yeah. The conflict that usually happen here is image. The image part. Everything if we build a new image, we will update this part. Okay. Yeah, good. Okay. Okay. This is a diagram. Yeah. Let's say, okay, yeah. This okay. Okay. This is Argo CD, their diagram. If you like, you can check their website. They see the CNI selection. There are a lot of factors that affect our CNI selection. You mean usually we consider this cost, complexity, product density, performance, and maintenance cost. And initially, our company is cost sensitive. So I try to use a category. Maybe you encountered this kind of issue before. You see your nodes still have a CPU resource, you still have a memory resource. However, you cannot apply new ports to your system. You also have pending, not enough resource, like this kind of issue. This is usually caused by the port density in the AWS. Is one specific node type you only can support to create maybe several ports, depending on the node type. If you choose the category, you can create a lot of ports in the same machine, more than the AWS native way, the CNI. However, this one also have a trade-off. I mean, the performance overhead. My preference currently I prefer using the CNI provided by the cloud provider. Yeah, the performance is better. You less complexity. It's very easy to maintain. If you use a category, you need to keep a lot of configuration, like a Helm chart. Yeah. A lot of things, and like metric server. Metric server also needs some customization to support the category. Yeah. This is ingress and the gateway. At first, our system is using ingress, and later I found several issues, like either using category to support several routing mechanisms, like how to based on the method, verb, or the cookie. How to this kind of routing the traffic to different services. Yeah. After several research, go to the gateway. I mean the ingress gateway. Yeah. In currently we have a standard like the Kubernetes gateway standards. Yeah. That's similar. The concept is similar. Yeah. The gateway also have a lot of give us a lot of flexibility. We can integrate a lot of CI/CD pipeline. You also can use the Flagger. We can canary deployment and progress the delivery. Ingress is the current way in Kubernetes. You can expose your service to the internet externally. The HTTP, HTTPS. For gateway, the new standard. Yeah, it's a new standard. It's in like service mesh. They have a E2. Yeah, you can use the E2 as this kind. Yeah. Service mesh also can use a gateway. Yeah, this support is kind of a mechanism. It's very flexible and also can integration with CI/CD pipeline. You improve progress delivery and flags, canary deployment, all these kind of things. Very useful. Okay, this is my lesson for figures. Maybe 5 months ago, I don't know how to learn something, where to learn advanced technology in the Kubernetes ecosystem. And later on find this kind of stories, data story and postmortems. I copied from the website and put something I found from the internet in the Google Sheet. And then it's one by one. If you're interested, you can copy them. Yeah. So it allows for you see the Kubernetes is quite complex. There's a lot of feeder point, maybe single feeder, single point feeder, and learn about there's something wrong, etcd wrong can get wrong, and also API server can go wrong, and even the node the load balancer, the main ways to get wrong. That's why I learned from here and learn about deep technology about Kubernetes. No, that's all.
I hope it is useful to everyone. Please feel free to follow us by any one of the links here. Thanks for watching. Enjoy your day.